So that is how you can solve any equation, really. Any equation you ever come across in your entire life. If you graph the left-hand side in y1, graph the left-hand side in y2, of course this is using your graphing calculator, and you find those points of intersection, all the x-coordinates for those points of intersection are solutions to that equation. So this is no different. When we graph the left-hand side and graph the right-hand side, okay, we graph this and we graph this, so there's the absolute value, there's y equals 2. Where they intersect, the point 2, 2 and the point 8, 2, those are our solution points. And so therefore 2 and 8 are the solutions to the absolute value equation there. Okay. So, number one, and this is a good question, I like this. Why might, and we don't have to write down the answer, we can at least talk about it. Why might you expect most absolute value equations to have two solutions? Why does it make sense here that most absolute value equations, like the one we just did, why does it make sense that most of those are going to have two solutions? Right, okay, so the shape of an absolute value is a V. And so some other, thing that's going to intersect that most likely is only going to hit it at two places. One on one side of the V and one on the other side of the V, and then that's it, right? So that's exactly right. And so that's why we wouldn't expect 3 or 4, because there's only two kind of parts to that V there. Okay. Is it possible for an absolute value equation to have no solutions? Is it possible for an absolute value equation to have no solutions? Try and think graphically up here. Think about how we determined that there were two solutions and what might a no solution situation look like. What might that look like? No intersection. Right. Okay, so in other words, if, for example, this horizontal line were below the absolute value there, yeah, if there's no intersection point, there's no solution. Exactly right. What about one solution? What might one solution look like? How can we only get one solution? Okay, so you're saying add another absolute value in. Well, we can get a single solution just from this situation alone, where we have one absolute value and then one kind of horizontal line. What's that? On the vertex. If that horizontal line crossed precisely through the vertex, it would hit only at one point and thus only give us one solution. So, in this situation, most of the time you can expect two solutions, but sometimes we could get one solution or sometimes we get no solutions. So we want to keep in mind that idea. Okay? Very good, very good. All right, so let's move on then. That's how we can do it graphically. And by the way, just in case you guys didn't know, right, your graphing calculators, I'll show you this here real quick, in case you've got one here. To graph these, all you do is you go to your y equals. Okay, to graph this left-hand side, you're going to type in a 2. Then you want to press math, and you arrow over to num, and there's the absolute value command, ABS. Now, my calculator has pretty type on it, so if I hit enter, it gives me those nice absolute value symbols. I can type in the x minus 5 in there, and then I have to arrow outside of it to do the minus 4. And then for the y2, I can just graph the 2 on the right-hand side of the equation there. And then if I graph that, there we can see the same graph that we just made. Okay? How can I use my calculator, though, to find the point of intersection here? What are the commands that I need to use? Do you guys remember? What are the commands that I need to use to find those points of intersection? Yeah, second, and then we can use the table. I also like using the trace command, and then we can just go down to this command right here, intersect. Also works real nice. Okay? So all you do there is you see your cursors on, whoops. All you do there is you see your cursor there. If you move it left or right, it's on that first curve. So we hit enter, and then it asks for the second curve. Oh my gosh, I keep pressing the wrong button. Okay, and then it asks for a guess. Now, because there's two solutions here, what I suggest you do is move your cursor close to one of the answers there and hit enter, and then it'll give you that intersection, 2, 2. And then if you want to find the other solution, you have to move your cursor for the guess part. You need to move your cursor over to the other solution, hit enter, and then you see it gives you the other solution too. Okay? So that's what that guess is used for. You need to move it so that it's closer to the solution that you want. Alright? But there it is. Boom. And you can solve any equation that way. So I could throw some ridiculously crazy equation at you that you would never want to solve. And as long as you can graph it correctly in the y1, graph the left-hand side in y1, graph the right-hand side in y2, you can solve it. Find those points of intersection. Okay. Let's continue on here. And we're going to look at, on page 78, how to solve these equations algebraically. Okay. So, to solve absolute value equations algebraically, that means using algebra, first, isolate the absolute value expression on one side of the equation the same way that you would isolate a variable. Then use the rule. If the absolute value of x is equal to a, where a is a positive number, then that means x can equal either positive a or x can equal negative a. Right? So in other words, if you see this kind of equation, absolute value of x equals 3. What is the number that would make this equation true? Negative 3 or 3? Yeah, two solutions, right? So that's why when you see this absolute value of x equals 3, that means x equals either 3 or, and there's that disjunction thing, x equals negative 3. There's two solutions there. Okay? So let's see this here in example 1. It's done for us a little bit. So you can see for letter A here, it's got absolute value of 3x plus 2 equals 8. So remember, the first thing they said to do, first isolate the absolute value expression on one side of the equation. So if you see here, here's our absolute value expression, but what's with that absolute value expression that we need to get rid of so we can isolate it? Well, that's inside the expression, but what else is on the same side that we need to get rid of here? The plus 2, right? So we have to subtract 2 from both sides, and you'll see we end up with the absolute value of 3x equals 6. Okay? So, like we did up here, right, where there's the absolute value of x, that means either x is 3 or x is negative 3. Here we're going to take 3x and make it equal to 6. 1 second. 3x equals 6, or 3x equals negative 6. And then you solve these individual equations. So divide both sides by 3 here, you get x is 2, and divide both sides by 3 here, you get x is negative 2. Question? Sure. Okay. Alright, so let's look at letter B. Alright, letter B has all these blanks in here. I'm going to skip all these blanks. I really don't like filling in those blanks. So we're going to just do it over here on this, in this space. Okay? Those blanks annoy me because I don't like having to fill in from what they want us to do. So I'll start by rewriting the equation over here. 3 times the absolute value of 4x minus 5 minus 2 equals 19. Okay. So the first thing we need to do here is to get that absolute value by itself. So, okay, oh, that's the Bonnie just left. Let's get someone in here. So Miranda, what's something that's with that absolute value that we need to get rid of there? So to get rid of the minus 2, we will what? Yeah, there you go. Add 2 to both sides. Okay, we're now left with 3, absolute value 4x minus 5 equals then 21. Okay, very good, Miranda. Let's go to Eve. Eve, at this point, now that we have 3 times the absolute value expression here, 4x minus 5 equals 21, what's the next step? What's the next thing we should get rid of? To start solving, or to keep solving. So good thought there. But what we want to do is we want to isolate the absolute value. So actually, anything that's inside the absolute value, we kind of want to keep it there. So then, what's the only other thing we have to get rid of? The 3. So divide by 3. Yep. Okay. So that's 3 times the absolute value. Those will just cancel. 21 divided by 3 is 7. And so now we have the absolute value of 4x minus 5, okay, equals 7. Okay. Since the absolute value of 4x minus 5 equals 7, that means either 4x minus 5 equals 7 or 4x minus 5 equals what? Negative 7. Yeah, exactly right. Okay? We need the 4x minus 5 to either equal 7 or the 4x minus 5 to equal negative 7. Either way, a 7 or a negative 7, when you take the absolute value of it, it will give us 7. So that's why we split this thing up. Notice we dropped the absolute value sign at that point, and we're just going to solve two individual little equations here. Okay, so the good news is we're going to solve them both in the same way, right? So for example here, to continue solving, what would we do? All right, so Andrew, what are we going to do at this point to continue solving these equations here? What's going to be our next step to get the x by itself? Yep, add 5 to both sides and in both equations there. Okay, so those cancel out. We're left with 4x equals 7 plus 5 is 12. And here when we add the 5, those will cancel out. We're left with 4x equals, and then negative 7 plus 5, negative 2. Okay. Thank you, Andrew. And then Patrick, last step here. What do we have to do to both of these equations here?
Divide by.
Yes, sir. So that gives us x is 3, or x is negative 1/2. Because negative 2 divided by 4 simplifies to negative 1/2 there. Okay. And so those are our two solutions. Wow, I did not circle that very well. Okay. Okay, there it is. So now they want us to graph the solutions. Okay, so to graph a single solution, you just plot a point on 3. There's one solution, and then we'll plot the point negative 1/2. So let's see here. Here's 0, there's negative 1, so negative 1/2 would be right there. Okay? So 3 and negative 1/2. Questions on any of that? Pretty straightforward, I hope? Yes? All right. Shall we do one more, or are you guys feeling okay about this? Does anyone want to see one more? Good. All right, let's do one more here together, and then I'll have you guys try one here. Okay, so let's look at number 3. Okay, again, our directions say, solve each absolute value equation algebraically, graph the solution on an arc. Okay, so, let's see, I'll just do this. Okay, so let's do number 3 together, and then I'll have you guys try number 4 on your own. All right. So let's go to Greg. So Greg, this absolute value equation, what do we need to do first here? There you go, exactly right. To get rid of the 1/2, multiply both sides by 2. So the 2 and the 1/2 cancel. We're left with absolute value of x plus 2 equals 20. And now we've isolated that absolute value. So yep, we're going to have x plus 2 equals 20, or x plus 2 equals negative 20. And then you just solve. So Greg, in each case, we solve by, yep, we're going to subtract 2 from both. And so you get x is 18, and then, yeah, you're right, x equals negative 22. So there are our two solutions. Okay. Ooh, now if we look over here, we go from 0, and then a tick mark, and then 8. So we're counting by how many each time here? 4s. So let's see here, 4, 8, 12, 16. The next one is going to be 20. So then 18 is halfway between 16 and 20. So we'll put that point right there. And then negative 22, again, negative 4, negative 8, negative 12, negative 16, negative 20, negative 24. So negative 22 will be halfway there, approximately right there. Okay, so there are our 2 points. Okay, go ahead, folks. Try number 4. I'll come around and help. If you need it. Okay, but go ahead, try number 4, please. Try number 4, please. Okay, go ahead and try that number 4. And graph your solutions, too, when you're done. Okay, remember, isolate the absolute value, and then break that up into 2 equations. Just make sure you're okay. David, you can get your book out and try that number 4 too, please, on page 78. Just make sure that you know how to do it. Okay, so we'll check it. Great question. And so, which one, if you had to pick one, which one would you start with? So I see what you're thinking there. Remember this negative 2, this next to absolute value, that means multiplication. So to cancel out, we would actually be dividing. So now that we think of it as dividing, we want to subtract 5 first, and then we divide. Okay, so good thinking. I see what you're thinking there. Yeah. Okay. So first you want to subtract 5 from both sides. Okay. Oh, so since you're subtracting 5 from this plus 5, so that's just going to cancel out because you're left with -2 and then absolute value of x minus 6. You see what I'm saying? When we have these absolute values, we want to isolate the absolute value, meaning it by itself. So what's still with this absolute value that we need to get rid of? Yeah. So how do you get rid of that -2? So I think it's again, but when you have -2 next to the absolute value, that means actually multiplication, right? So how do you get rid of -2 times the absolute value? What you do? Not add it. What undoes multiplication? What's the opposite of multiplication?
Divide.
Division, exactly. Divide both sides by -2. Okay? And then you break it up into the two equations. Like we did here. Yeah. You get this okay, Jake? Sort of. Okay. Good. Yeah, no, you are looking good. Very good. Okay. Looking pretty good. Nice and good. We'll see here. Okay. Give you like another 30 seconds here or so, and then we'll go over it. Like 30 seconds or so, and then we'll go over this one. Okay, let's take a look here. So, Josh, how did you start out here for number 4? What did you do for your first step there? Yeah, great. Subtract 5 from both sides. Perfect. Okay, that leaves us with -2, absolute value 3x minus 6 equals -4, and then what? Yes, great. Those cancel out, and so we're left with just the absolute value of 3x minus 6, and that's going to be positive 2. Okay, and then what do we do from there?
I'm still looking at it.
Great, yeah, so we're going to have 3x minus 6 equals positive 2, and then also 3x minus 6 equals -2. Great, and then we just solve from here. So you want to just tell me what to do? Can you tell me what to do from here? I know you didn't get the whole way, but what should we do now to solve each one of these equations here? Yep, and we can also do the same thing here, right? Because they also have a -6. So we're left with 3x equals, let's see, 2 plus 6 is 8. And here, -2 plus 6 is 4. Okay? And then what's going to be our final step here? We have 3 times x equals 8, or 3 times x equals 4. So to undo that, what should we do? Yeah. You're right. Divide by 3, divide by 3, divide by 3, divide by 3. Oh, you don't like the fact that there's going to be fractions here? Yeah, we get 8/3, and we get x equals 4/3 there. Okay? Yeah, so if you look here, ooh, Now this is kind of helpful. If you look, each tick mark here we're counting by 2/3. So if this first tick mark is going from 0 to 2/3, how many thirds will this be? 4/3. Yeah. So we can put a point right here. Right, if that's 2/3, then another 2/3 would be 4/3. Another 2/3 will be 6/3 or 2. Right, and so on and so forth. And then 8/3. Well, let's see here. So again, 2/3, 4/3, 6/3, 8/3. So that's where the other point would go right there. Okay. I don't know if I like that very much. I don't know that they counted by 2/3 or whatever, but you know, it is what it is. Okay, I guess that kind of helps us with graphing it. Okay. All right. I want to look at 2 more problems, and then I'm going to get you guys started on your assignment, because yeah, that's all I wanted to look at. Okay, really. So we're almost done. All right, let's look at 2 more here, and then we will be finished. And one of them is already done for us. So if you look at the very next page there on 79, at the top of 79, okay, you can see that the header here says absolute value equations with fewer than 2 solutions. So you have seen that absolute value equations have 2 solutions when the isolated absolute value expression is equal to a positive number. Okay, and then we'll see what happens when we're equal to other things too. So let's take a look here for letter A. Okay, so for letter A, they solve just like you guys normally would, right? Subtract 2 from both sides. We end up with a -5. Absolute value of x plus 1 equals 10. Then divide both sides by -5, and we get -2. And then we get no solution as our answer. And the reason that we're given here is that absolute values are never negative. And if you look, right, look at what they're trying to say here. We're trying to say the absolute value of something is equal to a -2. But absolute value never makes things negative. Absolute value always makes things positive. Okay? So the absolute value of x plus 1 and it equals a -2 is impossible. That's why there's no solution. Okay? Now you might be thinking, but Mr. Widmeyer, didn't we make things negative before when we were solving? Like back over here in the problem we just did, okay, what Joshua was telling us to do here for number 4, right? We got, you know, the absolute value of 3x minus 2 equals 2, or sorry, absolute value of 3x minus 6 equals 2, right? We got this. And then we said that was 3x minus 6 equals 2, or 3x minus 6 equals -2. And you're right, we did make that 2 there a -2. But that wasn't where we had our problem. The problem is when we had this number right here, if that was equal to a -2, it would be impossible, because you can't take the absolute value of anything and end up with a negative number, okay? Here, it's part of the solving process. Right now, the absolute value is equal to a +2, and so then to solve it, we say that means either 3x minus 6 equals +2 or 3x minus 6 equals -2. But if the absolute value equals a negative number, you are done. Game over, okay? No solution. So then what about here with letter B? What's going to happen? Well, I guess I'll just do the blanks here, just to have them filled in. It tells us to add 3 to both sides, right? That makes sense. We're going to add 3, so that means this is going to equal 0. Okay? To get rid of the 3/5, we can either divide both sides by 3/5 or multiply by the reciprocal 5/3. But what's 0 times 5/3? 0. It's gone. Then it says rewrite as one equation. So now here's the trick. Absolute value of 2x minus 4 equals 0. At this point, since we've isolated the absolute value, shouldn't we break it into 2 equations? But if we break it into 2 equations, it's going to be a +0 and a -0. But it's just 0, right? It's the same thing. So that's why we only have one equation here. Just one. Okay? Since it's equal to 0, the absolute value equals 0. It's not +0, -0, it's just 0. And so when we solve, we'll add the 4 to both sides, right? And get 2x equals 4, and then divide both sides by 2, and so we get one solution. And so there's that one that Jake was talking about earlier, where the horizontal line is going to hit right at the vertex. Okay, so that's where that is. One solution there. And there's the situation where we have no solution. Okay, algebraically, you come up with something that's impossible. So no solution. And then same thing here, we come up with only one solution. Okay, so that's the idea. Any questions on any of that? Great. So then your homework is, let's see, I have it written down here, I think. I would like you to do numbers, start on page 81, and I'd like you to do numbers 1 through 15, the odds, please. 1 through 15, just the odds. Okay, 1 through 15, the odds. And please follow the directions that are being asked. So for example, in numbers 1 and 3, you're asked to solve it by graphing. Please graph it, okay? You guys have the skills, that way you can practice your graphing, but then also, get the solution that way too, okay? So please go ahead and get to work on numbers 1 through 15, the odds, okay? And I'll come around and help you or cajole you or whatever I need to as necessary, okay? To correct the whip. All right. So again, 1 through 15, the odds.